Okay, let's take a look at number 1. Go through the process. What's the domain? X cannot be, we saw this one before, can't be plus or minus 1. Set the denominator to 0 and solve. Not to be mixed up with the x-intercepts, set the numerator to 0 and solve. So I got an x-intercept that's 0, which would be the point 0, 0 if I plug in 0 for x. Asymptotes, there's no horizontal because the degree of the numerator is greater than the degree of the denominator. There are vertical. Right? If I were to factor this, we could have done that first. Then there's no like factors, so those are both vertical asymptotes. X equals 1 is a vertical asymptote. X equals negative 1 is a vertical asymptote. And in this case, we have a slant. Because if the degree of the denominator is 1 less than the degree of the numerator, have a slant. So if I divide this into this, I'll get a linear function, right? Because they're 1 degree apart. Now, we have to be careful now. We can't use synthetic division because I have a quadratic that I'm dividing by. So I have to use long division. 0x squared plus 0x plus 0. X squared goes into x cubed x times, subtract. Try that again. That. And then we multiply. X times this thing is x cubed minus x. That's over here. I put it in the wrong place. Now we subtract 0, 0, negative x. Bring down the 0 if you want. And that's it. Okay, so that's a little confusing. See if we can figure that out. The original function f of x can be written as the quotient plus the remainder over the original denominator. Okay, so this function, believe it or not, is the same as this function. And then why did we do that? Well, the real reason we did that was to find our slant asymptote, which is y equals x. So that's this guy. Vertical asymptotes. Ooh, this is going to be a tricky one. X equals 1 and negative 1. And what else do I have? An x-intercept crosses through there. Is that all I got? Okay. So what are my options here when I'm graphing this thing? Well, it could do this, right? Or it could do this. And then the same thing over here. It could do this, or it could do this, right? And then in between, I'm going to have to think about that. So let's decide which one it is by just picking a test point. So I just want to know what happens when x is, let's say, 2. That should help me. Is it above this line, y equals x, or not? F of 2 is 8 over 4 minus 1 is 8/3, which is 2 2/3. Right there. And that's it. That's all I need, because then I know it has to hug this line, because it's a asymptote, it has to hug this line. And then my guess is that it's going to be down here. I can do another test point. Okay, and then if I have to hug this line, and I have to hug this line, that's one option there. Or what else can happen? It could do something like, so it could do that, or it could also do this on either side. It could look like a little parabola. Okay, so I just need 2 more test points to figure out what's happening. Really, I just need if it's positive or negative near 0. So I would probably take f of 0.5 and f of negative 0.5 as my test points. So I say 0.5 cubed over 0.5 squared minus 1. Can we get away with just deciding if this is positive or negative? Well, I know that's going to be negative, right? Because this is positive, and this will be negative. 0.5 squared, 0.25 minus 1. So when x is a half, My output's negative. I don't even care what it is. I know it's going to do this because of my asymptotes. And then on the other side, does it come back down or does it go up? Well, let's take a look. F of negative 0.5 would be negative 0.5 cubed. That's a negative number. And then on the bottom is negative 0.5 cubed minus 1 is, or squared, I'm sorry, squared. That's also a negative number. 0.25 minus 1. Negative over negative is a negative, so it should come back down like this. A weight correction there. You probably noticed my error. On this side, this is negative number, not negative 1. This thing is negative, and on the denominator, that's also negative. That's a positive, not a negative, so that means it's got to go up here. So I get this graph that hugs those two lines and satisfies my two test points. This piece hugs the two lines, satisfies one test point. This one I was just pretty happy I was going to do that because of the symmetric nature of this thing. And that is the graph of that function. So let's see, what am I missing here? Let's go back to the one that I said we'll do later, this guy. So this is similar. We had, let's review, vertical asymptote, horizontal asymptote, two vertical asymptotes. And then this one's a little weird because a lot of times the x-intercepts tell me what's happening here. So it either does this and crosses and then has to hug that axis. So it'd have to go down and come back to it, which does happen sometimes. Or it does this, crosses, and then hugs. So those are one of the two cases. So it's just a matter of test points now. If I chose, I want to know what like f of 10 is, then I know what side it ends up. Does it end up on the positive side or the negative side? So that should be positive, right? 80 over whatever the denominator is. Plug it into the factored form, 15 times 16. Doesn't matter what that is. I know that it's positive, and it's going to be a small number, right? That's the idea of horizontal asymptotes. So it's going to go, it has to cross, so it should start here, cross, and then come back down, and then go down forever. So on the back side, what happens at f of negative 10? That would be negative 80, and then a negative times a negative, right? I don't even care what that is. It's negative 5 and negative 4, but that just should be a negative number, 3 negatives. So that means it has to be down here, and you ask yourself, is it going to cross the x-axis like this one did? It does not, because there's no other x-intercepts. That's why the x-intercepts was helpful. And then on this case as well, there's no x-intercept, so it cannot cross this x-axis again. So it has to either be this guy or this guy, one of those little parabola things in there. And in order to do that, I'd have to just pick a point in between 5 and 6 negative and do a little test point. And I don't care what it is, I just care to see if it's a negative or positive value. So again, 8 times negative number is negative. Negative 5.5 plus 5 is negative. And negative 5.5 plus 6 is positive. So that means input here, output positive. That means everything's got to be positive because it cannot cross the x-axis.